Ever pondered how your smartphone identifies your voice from a room full of chatter? Welcome to the intriguing world of neural networks, the brainchild of artificial intelligence. These intricate systems, designed to mimic the human brain, have been transforming the technological landscape, paving the way to a future where machines can learn, adapt, and even make decisions. Neural networks are modeled after the human brain, hence the name. Just as our brains are made up of billions of neurons interconnected in a vast network, neural networks consist of layers of artificial neurons or nodes. Each of these nodes is like a miniature decision-making center, processing the information it receives and passing it on to the next layer. Much like the human brain learns from experience, neural networks learn from data. The more data they are exposed to, the better they become at recognizing patterns, making sense of complex relationships, and predicting outcomes. They can be trained to recognize images, understand speech, translate languages, and so much more. The beauty of neural networks lies in their adaptability. They are not programmed with specific tasks in mind, but learn from the patterns they discern in the data they process. This learning capability is what makes them so versatile and powerful, enabling them to tackle tasks ranging from voice recognition on your smartphone to autonomous driving in self-driving cars. But what's even more fascinating is how neural networks have permeated our everyday lives in ways we often don't realize. Whether it's the voice assistant on your phone, the recommendation system on your favorite streaming platform, or the medical diagnostic tool that helps doctors detect diseases early, neural networks are at work behind the scenes, making our lives more convenient, efficient, and safe. Hold on to that thought as we delve into the top 5 neural networks that are transforming our everyday lives. First up, we have voice assistants such as Siri, Google Assistant, and Amazon Alexa. These virtual helpers represent a fascinating application of neural networks. At their core, they use a type of neural network known as a recurrent neural network, or RNN for short. These networks are designed to recognize sequential data, which is exactly the kind of data that our spoken words represent. But it's not just about recognizing words in a sequence. These smart assistants have to understand our speech in the midst of noisy environments. Whether you're in a bustling city street or at a rowdy family gathering, these assistants can filter out the noise and focus on your voice. This is achieved through a process known as noise reduction, which is facilitated by the neural network's ability to learn from a vast amount of data and adapt to different sound environments. Once they've recognized our commands, these virtual assistants perform a variety of tasks. They can fetch us the latest news, play our favorite music, and even tell us a joke when we need a pick-me-up. But their capabilities extend beyond entertainment. They can manage smart home devices, adjusting the lighting or heating at our command. They can set reminders for us, ensuring we never forget an important meeting or a friend's birthday. These tasks are performed by interacting with other software and hardware systems. For instance, when you ask Siri to turn down the lights, it communicates with your smart home system to execute the command. This level of integration and interoperability is what makes these assistants truly smart. So the next time you ask Siri for the weather update, remember you are interacting with a sophisticated neural network. It's a system that has learned from millions of voices and commands to understand and assist you in your everyday tasks. It's a testament to the remarkable progress we've made in the field of artificial intelligence, and a glimpse into a future where our interactions with technology become more natural and intuitive. Ever wondered how Netflix always knows your favorite genre of movies? This is not a coincidence nor magic, but the work of neural networks in recommendation systems. You see, these advanced algorithms analyze your preferences, viewing history, and even the minute details like how long you paused on a particular title. They work in a simple yet sophisticated way. Every time you watch a movie or a TV show, the system is learning. It's taking notes on what you like and what you don't. This data is then processed and patterns are identified. The neural network uses these patterns to predict what content you might enjoy next. It's like having a personal assistant who knows your taste better than you do. And it's not just Netflix. Other platforms like YouTube and Spotify use similar systems, tailoring your experience to match your unique tastes. So your perfect movie night is courtesy of a clever neural network. Moving on to a life-saving application of neural networks' medical diagnostic systems. These systems are a game changer in the world of medicine, leveraging the power of neural networks to assist in diagnosing diseases, analyzing medical images, predicting illnesses, and even designing personalized treatments. Let's start with diagnosis. Neural networks have the capability to sift through vast amounts of medical data, recognizing patterns and anomalies that might be missed by the human eye. They can identify markers of diseases in blood tests, genetic profiles, and more, with a level of accuracy that often surpasses that of human doctors. Next, we have medical imaging. Neural networks are revolutionizing the way we analyze images from MRIs, kinetic scans, and X-rays. They can detect the slightest abnormalities, like tiny tumors or minute changes in brain activity, which could be early indicators of serious conditions. Now, on to predicting illnesses. Imagine if we could foresee the onset of a disease before any physical symptoms appear. Neural networks make this possible. By analyzing patterns in a patient's health data over time, these systems can predict the likelihood of them developing certain conditions in the future. This allows for early intervention and potentially a better prognosis. Finally, we have the design of personalized treatments. Every person is unique, and so is their response to treatment. Neural networks can analyze a patient's individual health profile, including their genetic makeup and lifestyle factors, to recommend a treatment plan that is tailored to their specific needs. This personalized approach can lead to more effective treatments and improved patient outcomes. Neural networks in medical diagnostic systems are truly transformative. They're not just crunching numbers or processing data, they're helping doctors make more accurate diagnoses, predicting health risks before they become serious, and creating personalized treatment plans that can save lives. These neural networks are not just smart, they are potentially life-saving. Our last two spots are taken by autonomous cars and machine translation systems. When it comes to self-driving cars, neural networks are the secret sauce. They're like the car's brain, processing a constant influx of information from sensors, cameras, and radar. The car's neural network is trained to recognize road signs, other vehicles and pedestrians, and to make split-second decisions based on this information. For instance, if a pedestrian steps into the road, the car's neural network processes this information and decides to brake, all in less time than it takes a human to blink. It's this ability to process and react to complex situations that makes autonomous cars a promising solution for safer roads in the future. But neural networks aren't just about making our commutes safer. They're also breaking down language barriers. Enter machine translation systems. These systems use neural networks to automatically translate text from one language to another, making it easier for people to communicate across different languages. The process starts with the neural network learning the syntax, grammar, and vocabulary of both the source and target languages. It then uses this understanding to translate the text, word by word, sentence by sentence. But it's not just a simple word-for-word swap. The neural network also considers the context of the sentence and the nuances of the language, ensuring the translated text maintains its original meaning. Machine translation systems have revolutionized the way we communicate and access information. With a few taps on a keyboard or smartphone, we can now understand a foreign language news article, a recipe in another language, or a message from a friend who speaks a different language. In both autonomous cars and machine translation, neural networks are the driving force, helping us navigate the roads and the world of languages more safely and efficiently. Whether it's making our commute safer or breaking down language barriers, neural networks are at the heart of it. So, what's the big deal about these neural networks, you may ask? Well, let's take a quick look back. Voice assistants like Siri and Google Assistant are simplifying our daily tasks with voice recognition. Recommendation systems on platforms like Netflix and Spotify are personalizing our entertainment. Medical diagnostic systems are leveraging neural networks to diagnose diseases and predict health risks. Autonomous cars are using them to interpret road signs and make decisions, while machine translation tools are breaking down language barriers. Collectively, these neural networks are revolutionizing our lives, making them more convenient, efficient, and safe. They're taking over tasks that would have been time-consuming or even impossible for us to do manually. They're making sense of vast amounts of data, learning from it, and using it to deliver personalized experiences. In the words of Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from magic. And that, my friends, is the magic of neural networks.